a Marshall Studio 15 I'm going to have a look at. These were built from about 1985 up to about 1992. Not in very many, apparently only about 1,000, who knows. It's got a 12-inch speaker, but it's unusual in that it has two 6v6 valves in it, so it's only 15 watt rated. I think it was the first very small sort of little combo that they made like this. Even though made in 85, still you can recognize all the features like modern amps. For instance, I've got some pictures of some equivalent ones that are on sale now. The DSL 20CR and this more sophisticated 2-channel version. As you can see, it hasn't changed a lot. The knobs, switches are even the same. Gold front panel and the actual knobs, etc. So what's special about this amp, if anything? Well, besides the 6v6 valves, it had a couple of special parts on the back we're going to look at. It's called the Studio 15. It was supposed to be very quiet. I'll look at the circuit diagram in a minute and perhaps look inside, check out what's going on. Very quiet. It has got DC on the first valve, DC heated valves that is. Try to keep the noise at minimum so that you can record off it without any background noise. This one has standard sort of controls, treble, middle, bass, no presence control, but a gain and an output, which is a master volume. These more modern ones have more controls and perhaps 2 channels. Now it's not that big, as you can see, compared to this is just a 12-inch extension speaker cabinet. It's actually bigger than the combo. So looking at the back, it's quite nice and deep. It's a single 12. It comes with a vintage G12, one of the first amps I think that used this speaker session that they made to try and reproduce the sounds of the early speakers. On the back, it's got a balanced direct out. Again, can be used in the studio. There's a headphone socket, and you can unplug the speaker and plug it in there, and it gives like half a watt. I did try it, sounds rubbish in my opinion. And there's also a line out serial number. There's a little bit of data there. A modern IEC socket, which is good. Fairly solid construction, just like all Marshalls. So you can get a bit more specification online all about it. It's also known as the 4001, and it's got a spec here, actual frequency response of everything, 15 watts, signal to noise ratios, all sorts of things that they were saying supposed to be special for the studio. So I'm going to have a look. Well, we'll turn it on later. One thing I have noticed that this hasn't been used in some time, these knobs are like seized up. They do not want to turn. You can turn them. That one turns alright, but these two don't want to turn. Nor does that one, or does that one. We've got one. I don't know why they're so stiff. We'll look at that as well. Just checking out the sounds of the Studio 15. For the gain and the master output. Now these, as I said, these are very stiff. I haven't fixed them yet. Master output to about 4. Now the tone control. Treble. First thing I noticed, it's very bright. There's a lot of treble. That is bright. Much too bright in my opinion. That's using the neck pickup on the guitar as well. That's got a huge range, the middle. Does cut the bass, and you hear the bass coming up near maximum. That's middle, treble down a bit. I turn up the gain from low, number 6. Let's go all the way up to 10. It's really beginning to distort. Go back to 4. Turn the master all the way up to maximum. With a little bit of noise has come up, which is from internal circuitry, not from the guitar. The reason it's so bright is because there's a bypass capacitor on the gain, so as you turn the gain down, the treble is still going all the way through. It's bypassing the gain control, so the treble just comes up and up and up. So we turn the gain a little bit, number 4, middle up. Really loud, still pretty trebly. Guitar on the treble setting. Really cuts through. It's quite a very clean sound. And if we turn the middle up, we've got the treble on 0. Good sound. That's with the gain about 5ish, treble right off, middle up, bass half, and the volume output level max. Now that's with that speaker. I'm gonna try it with an old Bulldog, Vox Bulldog speaker, and see if it makes any difference to the sound, or whether it's the speaker that's generating all the sound. I've disconnected the speaker in there and connected up to a Vox, an old blue Vox Alnico, a 12-inch Bulldog speaker that's in there, and kept the settings the same as I was using just a second ago. To me that sounds better. It's also even louder. It's very crisp, bright, and a better sound, but it's a much more expensive speaker. So next thing I'm going to do is I'll just show you that disconnected the speaker and plugging it into the headphone output socket. Let's just see what volume that gives, which is a so-called attenuator. I've left the controls the same, and this is the sound you get now. Well, it's very quiet, but it's also sort of distorted, nothing sort of sound. And that's with the output on maximum, and the gain. If we just push the gain up, I think it would just get more and more distorted. I'll turn it up to maximum. Well, it is bedroom level, and if you like that sort of distorted sound, it will suit you. You can put headphones on. I assume it would sound about the same. The only thing I reckon you can do with this sound that might make it a little better is to make this treble not so bright, so maybe pass through a bit more frequencies than just the very high treble. It does bypass it all on the gain control, or possibly move it to another position in the circuit so that it's not affected by the gain control. And so pretty good sound, I think. I think it's very loud for 6v6s. I'm going to have a look inside. It's very easy to remove the chassis from the cabinet. Just take the back panel off and undo these 4 bolts that are on these straps on the top, and it just slides out backwards. You've got a heavy duty earth screen of aluminium stuck to the top. This is now upside down. Anyway, the chassis, so we slid it out. It doesn't weigh very much, and you can see immediately that the transformers are pretty small. So if we've got the 2 output valves and 2 preamp valves. A couple of things I noticed straight away. You can got some dates on here. This transformer's got 88.9, which means it's made after 1988 when this was manufactured, and there's also a date code on the capacitor. It says 8811, so we know it's made after November 1988, so the end of 88 or beginning of 89 it must be made. Now on the back panel, it's upside down at the moment, but it's a little information here, including the fuse 500 milliamp model 4001, 240 volts, input power 65 watts, output power 15 watts. And there's a sticker on here where it must have been originally supplied to, which was in, I know it's upside down at the moment, is that Germany or somewhere. The valves have been changed. It's now got some Fender groove tube GT6V6s have been put in. And these two here, which have got little aluminium, or actually they're steel screening cans on them, ECC83s. I mean, I've got a groove tube one and a ruby tube. So they've been changed from the original. I'll just turn it over and we can have a look inside. Looking inside the chassis, is another date code here. Drake transformer 1088, again the end of 1988 when it was made. And you can see a circuit board with all the pots mounted on all the components, very neatly done. Bias pots for the output tubes. It's got a sticker where it's manufactured, whoever signed it off, 4001. The resistor there, when you unplug the speaker to use headphones, is 10 ohm for 25 watts. Some components mounted on the output valves for stability. Power cap. It's all very neatly done. So you just need to look at some of these components here just to see if you wanted to change the input cap. They're all, luckily everything's marked on the circuit board so you know where everything is, which helps because online you can get circuit diagrams. There's 2 circuit diagrams online. This one, the later one, dated 1988, is neatly laid out, very easy to read. There's no voltages on it, but if you look at, it does tell you about setting the bias. Good balance visually at clipping into 8 ohm load, crossover distortion just visible. But the original issue of the circuit diagram dated, well, this has been updated, issue 3, 1986, but it was drawn differently, and it's a bit more difficult to read some of this writing that's been written in by hand. So there's a bit more information here, but it's got voltages on, which is very useful. 398-357, 347, 316 volts, 335, 307, and then on the 1.7 volt, the phase splitter, 40 volts, looks like 48.5, 35.5, so a negative 30 there to the on the bias, negative 30, and there is the circuit that generates the bias voltage off of the main power supply rail 390 volts, taken down to -60, and then it's taken down again on these pots. So this circuit is more useful than the other one. Capacitors and pots, so it's the circle around 1.45 there, so it's easier to see where you can mod the circuit from this drawing though. As I said, it sounds very bright. There's the, when you turn down the input gain, this capacitor bypasses the trebles into the amp all the time, so as you turn it down it gets brighter and brighter and brighter. The middle and bass control, the bass is over here, it's just cutting the treble off just by loading this point up here by cutting the bass down. Nothing is great about that, but the treble, it bypasses through this capacitor, 220 picofarad, so it's not a lot, just very high frequencies. You can put a much bigger capacitor in here and get more upper range control on that treble, not so sharp. It's probably quite useful to change that cap. Middle part here, and the master, it's got twin pots just loading down the output from the phase splitter, and it just adjusts the output from the phase splitter, how much goes off to the output valves here. So it's just like volume controls on the output valves. Nice big grid stoppers, which are good. The bias section, long-tailed phase splitter. Input just comes in 33k, 1 meg, nothing special. Quite a small capacitor here, so there's no extra bass lift on the gain on here. 1.k, 500k, pretty normal. And then there's a bit more gain lift here after the tone control. This one has got a bigger capacitor, 22 microfarads. I mean, you could put a bigger capacitor in here if you want more low end. Then it just comes out through a N2 into a 1 meg, so there's no load in there. It has a bigger capacitor here this way, which is I don't know if that's necessary to have a big one there and a small one there. What is, it goes off to D, line out, and the speaker plugs in there, and there's the headphones. It's got the 10 ohm which goes on the output valve. Transformer here, transformer. They've got some feedback, 100k to this point here. They still decided to use feedback off the speaker here, speaker output. There's also a completely separate winding for the balanced output on a separate transformer winding, which is quite an expensive thing add on. Just to make this transformer its own winding. Yeah, the feedback goes here, 100k to a 4k7, I believe. So you could adjust the feedback if you want, take it off, make a different sound, or have a variable pot. So it's very straightforward circuit. The filament heaters, the output valves and the phase splitter adjust AC, but then they've got a bridge rectifier to turn it into DC, 1000 microfarad capacitor, hum balanced, and filament to V1. Just so that there's no hum from the filaments. I don't find it's normally a problem, but I guess they thought they would absolutely minimize it, as it's called the studio amp. All the capacitors are marked. It's like this one here, I was talking about C1, and the other one C2, they're here. C2 and C1. If you wanted to change them, it's pretty easy. You could either do it from, we really need to lift the circuit board, but you could do it if you snap them off and lift the legs poking up. Now these pots, they are stiff. You cannot turn them without a lot of force. I'm not sure why, whether they've used grease or something that's solidified, I don't know. I'm going to have a look at that. Trying to fix these knobs that are so stiff you can't turn them. I'm going to have to take the amp panel out so I can get to the pots and find out what's the matter with them. Now some amps, the knobs are very difficult to get off because they're not held on by screws or grab screws. They've been pushed on, and Marshall ones are particularly hard to get off. You just can't, they just don't slide off even with your fingernails or anything. But so you just take a piece of wire that will fit behind the knob, just get it wrapped round, and you can just do a straight pull and it'll come off, and you don't damage the front panel or the knob or your fingers. Then you can undo these fixing nuts, and the panel will be able to get the circuit board out from inside and try and work out why these pots won't turn. With the nuts taken off, you just push the circuit board back, and it's not secured in any other way, just got wires holding it, and you can push it right back and you can actually get to the underneath. If you want to change any components, it's very straightforward. But these knobs, they don't turn. Except one of them, that one turns, but the others are seized. I'm going to try some, see if we can get anything down the shaft of these things, but I don't know what the problem with them is, whether it's a manufacturing fault. There's no E-clip anywhere. This one started to move. This is contact lubricant cleaner. Just try and get it to run down the shaft, and that one's beginning to move, which wouldn't move before. This one still won't move. That one is moving. I'll try a bit more of this, and I'll have to try and move these, see if it frees up. Fix the control board back in, put the knobs back on, making sure they all work and they will turn fine. Plugged it in to a speaker and turned it on, make sure it's sounding good, and we're just checking it out. Okay, guitar turned up. So, and the tones available. Turn the controls down. Lots of bass. Treble. Middle. And the combination, say about 50%. That's gain halfway up, gain down. Not go bright. And with the gain all the way up. String noise, treble down, bass down, that's with the level down pretty low, so it obviously goes very loud. Yes, very loud. Gain down to about 4. So good sound all around. So I'll put it back in the cabinet. I could check the bias, but it sounds fine. I might just check that in a second. The Marshall Studio 15 uses 6v6 output tubes unusually. Then they would normally use EL34s, and this is the ones that are in there, not original, but these are Fender ones, Electro Harmonics GT. Now the original 6v6 was a little bit smaller. Here's a Bremer 6v6 GT, and I've got the Evo here Mark III, which I can test the performance of these valves, make sure that they're well matched and they're working okay. Press the valves in and out. With the Bakelite base, some people try and pull the glass, and you can actually pull the glass tube out of the base. In the books for the 6v6, 45 milliamps. Testing the first valve, we're looking for 45 milliamps, and we're getting even up to about 48. And with this machine, you can also measure the gain, or the milliamps per volt. According to the book, it should be 4.1. That's on 0. I do the test and I adjust this scale, and it's reading almost spot on 4.2. That's a really very good valve indeed. Testing the second valve. This one's almost exactly the same. Which set to 0. Hits number 1. I didn't even move this from the last one, so these two valves are a perfect match pair, so it's exactly what you want. Just checking the operation of the circuit. The output from the phase splitter goes to the output valves to 100K grid stoppers, one to each valve. I put probes to the oscilloscope on those points, and you can see the output from the phase splitter, yellow and red. You can see that one output of the phase splitter is fractionally larger. They should be identical, which means that the circuit here, which has got compensation on it, 100K and 120K on the anodes to try and compensate for that, isn't working perfectly, as one side is still slightly higher than the other. It's fairly symmetrical on the overload. Usually this circuit has a cathode bias as well as a fixed bias on these pots here, so it's got best of both worlds. So current flowing in each output valve quite easily by putting a voltmeter across these resistors. And checking the bias on the two output tubes, there are two little potentiometers in there, little black things, where you can adjust the bias. What should you set the bias to? Well, according to the instructions here on the circuit from Marshall, it says set them for good balance visually at clipping into an 8 ohm load, crossover distortion just visible. But first of all, I'm going to check the bias, see what it is. Now, how do you do that? Well, online you can actually get bias tables for 6v6, and this is the plate voltage, and this is suggested bias between hot and cool. You'd probably set it in the average. It says 18 milliamps. So how are we going to measure that? Well, this circuit's unusual in that it has a variable bias. They suggest minus 30 volts pots there, and it's got cathode bias here on each valve. It's two individual resistors, which makes life easy for us. So we can measure the voltage across there and work out what the milliamps are flowing. Now, first of all, we need to know what the plate voltage is, and as I put a meter on there, it's exactly 400 volts, which is the actual upper end that they suggest that you run the 6v6 at. So this amp is getting the most out of a 6v6 that you can possibly get. So that is the voltage I'm measuring there, and I can measure the voltage. Luckily, those resistor and capacitor are mounted on the valves. They're very easy to get to. So I put a meter on one of them, and it's reading 7.5 volts, and we can work out now what the current flowing is, because 7.5 volts 270, just using this little calculator, be 7.5 divided by the resistance 270 has given us 28 milliamps according to the chart. That's too high. They suggest 18, so it's way off. So I'm going to also put a meter onto this point here where they suggest minus 30 volt fixed bias to the tube, and see what that is reading. I should be reading minus 30 approximately according to their circuit diagram. It's reading minus 26 at the moment. So I can adjust one of these pots down here, hopefully with a long screwdriver that just fits in. And I'm turning it now, and I can get minus 30. Almost spot on. That's close enough. But the voltage has dropped to 6.5 volts now, so that is now 24 milliamps. According to this, it's still running hot. Maybe that's what Marshall wanted. I'm going to check put the probes on the other valve and make sure that they're running the same at least. Checking the other valve, it's running minus 35 fixed bias, and it's 4.8 volts on the 270 ohm. So I've got to try and just get to that pot with this long nose screwdriver and turn it. Oh, there it goes. So turning the pot, set it to same as the other one, near enough, minus 30. But now the cathode is 6.35. So the other one was 24 milliamps, 23.5 milliamps. So I guess it's 23.5. If that's come out, I guess that's close enough. It's running hot hotter than they suggest. 400 volts, just fractionally under. This is plate cathode to anode. Well, we've got to take 6 volts off, but it's running hot. It's running hot indeed. I decided to adjust the current through the cathode resistors to the same voltage, which is 6 on that one, and just move it across to the other one. Also same, just by adjusting a tiny bit on the potentiometers for setting the bias there. 6 divided by 270 is now 22 milliamps, which is close enough to how it was running hot. Measuring this power output of the Studio 15, if we look at the chart, it says with an 8 ohm resistor. I've drawn out this chart, and the power output depending on the volts across the load. So there's supposed to be a 15 watt amp, and there's the 8 ohm curve at 15. Should be just about 11 volts. Just over 11 volts. So I've got the meter on the 8 ohm load up there measuring the RMS, and I've got the waveform so we know when it's hitting maximum without distorting, and the 1 kilohertz tone. I'm going to turn up the red is the input to the output valves, and you can see I can't push it any further because it's just peaking out, so I'm going to leave it there, but I'm going to turn the output up here, output level, until it peaks out there. It's just, you can see it, the curve's bottoming out as it hits the maximum voltage. It's lost its sine wave shape a bit, but the output across the 8 ohms is only 10 volts. And according to the chart, 10 volts output is giving you into 8 ohms about 12.5 watts. To get 15 watts it would have had to go up to about just a little bit higher. 15 watts would be about 11 volts. It's a little bit off. You can get there if you start distorting the output and push it into square waveform, but well, it's about 12.5 watts anyway with a sine wave. I mean, I can push it into square wave, and then you got like 13 volts, but that's not what we're looking for. 10, 15, 20, 25, nearly 30 volts peak to peak across 8 ohms. You want to double check the RMS. Although this amp sounds loud, I just can't get 15 watts out of it, so I'm not sure what's going on. Another thing I will mention at this point is that some people say, can you convert it to 6L6s or even EL34s? Not a good idea. The mains transformer is pretty small. It's a very small transformer. 6V6s run at very low heater current. They were designed to use in cars, so you didn't flatten the battery. They run at low heater current. 6L6 run at about twice the heater current, and EL34s I think run about 4 or 5 times the heater current. You'd overload this transformer badly. It'd run hot. It would also cause the HT to generate a lot of noise on the HT. It'd be awful. This amp was designed for 6V6s. They got the most out of it. They run them at 400 volts, about as much as you can go on a 6V6. And with the size of the transformer, they've also using 6V6s because they're trying to make it quiet, and the 6V6 is quiet. It doesn't make a lot of noise in the transformer, so it doesn't get through the circuit with the low heater currents in the transformer. So the whole amp was designed around 6V6s. If you want more power, I suggest you buy another amp with bigger valves and transformers in it. The Studio 15 finished, put back together. The controls can be turned now. Before they were C solid, so just checking the sound. Guitar just plugged in, nothing else. Treble, middle, bass, so, and output. I put the gain on about 4 and keep the output down a bit at the moment. So treble control, middle control. Has a lot of range, and the bass. So they've got a good range, fairly clear sort of sound. That sounds fine at low volume. Then you can, let's turn it up a bit. So that's all working good. Now I have got the old Ampeg Jet, really old 1965 amp here, just to compare the sound of it. There's another one I had to fully service. So the clear sound. Total different sort of sound, much brighter in my opinion than that. This is, the Marshall's quite solid, very muscular sort of sound. The overdriven on the Ampeg. I think it's a little bit clearer than the Marshall, seems to muddy up. So with the gain turned up full, it gets a very sort of overdriven sort of sound, which is what you might want. So there's the Studio 15, all finished, looking pretty good for its age.